Hello and welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to do the basics of polynomials and then zeros of polynomials. So are you guys ready for this session? Just comment in the chat and let me know if I'm audible and visible to you properly. Welcome to the class, everybody. So we'll do polynomials from the very basics, the basic terminologies which comes in a polynomial. We'll do those and then we'll be doing zeros of polynomials and we'll be doing some questions on the basis of those concepts. So are you guys ready? Just comment over here. Are you able to hear and see me properly? Hello Nilesh, welcome to this session. So let's wait for some more seconds, let other students join as well, and then we can start with the session. Just comment in the chat, guys, if you are able to hear and see me properly. Hello Nilesh, welcome to this session. So you know that polynomials, see, you have already been studying polynomials since grade 7, right? So in grade 7, in grade 8, and now you're in grade 9. I'm doing good. I hope you're doing good as well, Nilesh. Hello Aryan, welcome to this session. Hello Anubhuti, welcome to this session. Okay, so let's start with it, guys. Let's start with the very basic definition of polynomials, okay? So over here, the first thing is we need to understand what is a polynomial and then degree of a polynomial and then what are coefficients and then what are monomials, binomials and so on. So the very basic thing I would like to ask, can you tell me, if I ask, is this a polynomial? Is this algebraic expression a polynomial? Hello Khuman, hi Mahiroon, welcome to this session. Is this algebraic expression a polynomial? X raised to the power 3 by 2 plus 3x minus 6. Just comment that in the chat so that I will be able to know if you're getting it or not. Hello Ramancha, welcome to this session. Okay, positive to all. What about other students? Can you tell me, is this algebraic expression a polynomial? Is your answer yes or no? Just let me know that quickly so that we can move on to other things. So you see over here, this algebraic expression is not a polynomial. It is an algebraic expression because it is expressing something in algebra, right? So it is an algebraic expression, but it is not a polynomial. The reason being, you have got fractional exponent of the variable over here. The variable is x over here. So due to the exponent of variable being fractional over here, this algebraic expression is not a polynomial. Very good. Yes, that is correct, Nilesh, Aisha. Suppose I ask you this question. Is this algebraic expression a polynomial? Can you tell me? Is this a polynomial over here? Okay, Nilesh. Just quickly tell me so that we can move on to the other things and we can do it quickly. See, if you will not comment, अगर comment नहीं करोगे मुझे पता नहीं लगेगा if you're getting it or not. So just quickly tell me if this is a polynomial. 3x raised to the power minus 2 minus 8x cubed plus 7. Is this a polynomial? Okay. So Harini and Aisha is saying it is a polynomial. No, this is not a polynomial because negative exponent of the variable is there. So it is not a polynomial. So basically a polynomial can have only whole number exponent of variables. Whole number exponent of variables. You got it? Apart from that, if you have got fractional exponent of the variables or negative exponent of variables, that algebraic expression is not a polynomial. This is not a polynomial because negative exponent of the variable is there. This is not a polynomial because fractional exponent of the variable is there. You got it? Now suppose I ask a question to you. Suppose is this a polynomial, guys? Is this algebraic expression is a polynomial? 17 raised to the power 8 by 4 into x cube plus 5x plus 6. Is this a polynomial? Just quickly tell that. Quickly tell that, guys. What about you, Aisha, Nilesh, Khuman? This is a polynomial. This is a polynomial. What I had said, whole number exponent of variables must be there. You just have to see the exponent of the variable. So the exponent of the variable is a whole number only. 3 is a whole number, 1 is a whole number. You don't have to bother about the coefficient. This is the coefficient, right? You don't have to bother about that. You just have to see the whole number exponent of the variable is there or not. If the exponent of each variable present in that polynomial is a whole number, then that algebraic expression is a polynomial. This is a polynomial. This is not a polynomial, this is not a polynomial. I hope that is clear to everybody. Basic definitions. You have been studying this since grade 7. Now you have got it in grade 8 and now you are in grade 9. Very basic concept it is, but it must be clear. Aisha, the 8 by 4 is the exponent of a constant. You got it? This is not a variable, Aisha. This is the coefficient of x cube. You just have to see the exponent of the variable over here. You got it? If it is not a whole number, if the exponent of the variable is not a whole number, then that algebraic expression is not a polynomial. I hope this is clear up till here. Okay, so the first thing we have already seen. Now the second thing is degree of a polynomial. Okay, so what is the degree of a polynomial? The highest exponent of the variable. You already know this, right? Suppose I am asking a simple question. What is the degree of this polynomial? 3x raised to power 5 plus 5x square minus 9. The highest exponent of the variable is the degree of that polynomial. So what is the degree over here, guys? Tell me. Exactly, highest exponent of the variable is 5. So you will say 5 is the degree of this polynomial. It is as simple as that, right? Nothing twisted in that. I hope it is clear. Now suppose I ask you a question. See, a polynomial can be in more than one variable as well. Yes or no? You can have a polynomial like this or not? Tell me. This is also a polynomial. This is a 2-degree polynomial in 2 variables. Yes or no? 2-degree polynomial in 2 variables. Is it clear to you? So if it's a 2-degree polynomial, you call it a quadratic polynomial. These are the names. If you have got a 2-degree polynomial, then that polynomial is called a quadratic polynomial. If it's a 1-degree polynomial, that is the highest exponent of the variable is 1, that is called a linear polynomial. If you have got a 3-degree polynomial, so that polynomial is called a cubic polynomial. If you have got a 4-degree polynomial, that is known as biquadratic polynomial. Biquadratic polynomial. So it's a 4-degree polynomial. 5-degree polynomial is quintic polynomial. So up till this only you remember normally. Apart from this, you don't have to remember by name. You got it? So if it's a 2-degree polynomial, it is a quadratic polynomial. Although I must have said it before this. If it's a 1-degree polynomial, it's a linear polynomial. If it's a 3-degree polynomial, it's a cubic polynomial. If it's a 4-degree polynomial, it's a biquadratic polynomial. If it's a 5-degree polynomial, it's a quintic polynomial. That's what I'm saying, Aisha. Otherwise, there is no end to it. So you don't need to remember the names of those things, right? So I too don't remember them. I'm being honest. You just have to remember up till 5. Otherwise, there is no end to it. Anybody can ask what is the name of a 1000-degree polynomial. Something like that can happen now because there is no end to it. So you remember up till 5 only. 5 is known as quintic polynomial. A polynomial of degree 5 is called quintic polynomial. Anumandla. I hope it is clear. Don't spam Anumandla. Yup. A 5-degree polynomial is called a quintic polynomial. And one more thing. It is not like that a polynomial will be in one variable only. It can have more than one variables. Yes, I can tell you. Wait, Nilesh, let me explain this one, okay? So for example, I had already said, suppose you have got something like this. So this is a 2-degree polynomial. This is a quadratic polynomial in one variable. You got it? This is a quadratic polynomial in one variable because it's a 2-degree polynomial and only one variable is there. So you will say this is a quadratic polynomial in one variable. But a quadratic polynomial can be in 2 variables or not? Tell me. It can also be there in the form of two variables. In the same manner, linear polynomial can also be in more than, it can be one variable linear polynomial. This is, you can have a 2-variable linear polynomial. You can have a 3-variable linear polynomial. Can you not have like this? Tell me. This is a linear polynomial in 3 variables. This is linear polynomial in 2 variables, linear polynomial in 1 variable. In the same manner, this is a quadratic polynomial in 1 variable. This is a quadratic polynomial in 2 variables. That can also happen. Exactly, degree 2 is there means it's a quadratic polynomial, whether it is having 1 variable, 2 variable, 3 variables, or any number of variables it can have. I hope it is clear. Exactly, Anumandla, that is correct. I'll explain that, Sumesh. Just have some patience, I'll explain everything. I hope it is clear to everybody over here. This logic is clear, right? That if you have got a cubic polynomial, so it can be in more than 1 variables as well. It can have, for example, I am taking an example. See, this is a cubic polynomial in 3 variables or not? Tell me. I can say like this. A cubic polynomial in 3 variables, isn't it? Tell me, guys. Yes. Hello, Sujay. Good afternoon. So this is a cubic polynomial in 3 variables. You can have like that. Yes or no? No, it is not like that. No, Anumandla. If it's a 3-degree polynomial, it's a cubic polynomial. Trinomial is a different thing. I will explain that. I haven't started explaining about monomials and binomials. I will explain that. If a polynomial is of 3 degree, then it is called cubic. If it is of 2 degree, it is called a quadratic polynomial. Again, I am repeating, a quadratic polynomial can have infinite number of variables. The degree has to be 2, then it will be a quadratic polynomial. I hope it is clear. In the same manner, you see linear polynomial in 1 variable, linear polynomial in 2 variables, linear polynomial in 3 variables. Any number of variables can be there. It will be still be a linear polynomial. Now, one more question in degree is asked. Therefore, I am asking you. See, it is an important question. Simple thing it is. Suppose what is the degree of this polynomial? Can you tell me? What is the degree of this polynomial? 3x raised to the power 5 plus x cube y cube plus 5x square. What is the degree of this polynomial? Exactly, Nitesh. That is correct. Nilesh. Let me see if you people can answer it correctly. So Anubhuti is saying 6. Sumesh, Vrushak, Aisha, they are saying 5. What about other students? Nilesh is also saying 5. Very good, that is correct, Anubhuti. See, whenever you've got something like this, now you see 2 variables are there. See, this term is giving you 5. This term is giving you 3 plus 3, 6. This term is giving you 2 power of the variable. So basically, the degree of this polynomial is 6. You got that logic? Suppose you have got 2 variables multiplied like this, so you have to sum up their exponents. Then you have to decide the degree. So over here, this is a 6-degree polynomial. Exactly. No, 5 is not correct, Naresh, over here. In this type of situation, 3 plus 3, 6 is the degree. You got that logic or not? Is it clear to everybody? In this type of situation, when it is multiplied, see 2 variables are, therefore I had taken this question. So over here, degree will be 6. Exactly. Vrushak, that's what I am saying. That you have to do when variables are separate. 1 variable, you got it? But over here, 2 variables are multiplied. So in that case, you have to sum up the exponents. And then, I hope it is clear now, Nilesh? No, Sumesh, what I am saying is, when you have got 2 variables multiplied, in any out of these situations, there is no variable multiplied. Have you seen in any out of these, have you seen a situation when variables are multiplied? No. Over here, variables are multiplied. So you have to sum up their exponents. So this is a 6-degree polynomial. I hope you got it. Any example you can take with Sujay. Suppose I am taking this. Suppose you got, suppose I am taking this, okay? So what will you say? What is the degree of this polynomial? X raised to the power 8, x raised to the power 5, x raised to the power 4, y raised to the power 5. What is the degree of this? Tell me. It is a simple logic. There is no logic. It is just a convention. Thanks, Matthias. I hope I am pronouncing. Very good. Yeah, over here, you don't have to take this 8 because you see 5 plus 4 is 9. That is the degree of this polynomial. I hope it is clear to everybody. Simple logic. So I hope the concept of degree is clear to you. Right? Not 14. 5 plus 4 is 9. How are you getting 14, Nilesh? Don't say that. Yes, Aisha. Okay. Now you got to understand monomials, binomials and trinomials. So monomials, binomials and trinomials, wait, maybe I'll go on to the next, wait. Okay, no problem, over here only. Monomials, binomials and trinomials, it depends on the number of terms. For example, I ask a question, what type of polynomial is this? Is it a monomial, binomial or trinomial? Tell me. I hope red quads, you just have to add up degrees when variables are multiplied. I hope it is clear. Over here you see x raised to power 4, y raised to power 5 is there. You cannot say that 8 is the degree. For each term you have to add the exponent of the variables. I hope you got it, red quads. So what type of polynomial is this? Tell me. X plus y plus z. It is a trinomial. 3 terms are there. It's a trinomial. 3 terms are there. So how will you decide the number of terms? Number of terms are decided by the number of addition and subtraction sign in between. You got it? So 3 terms are there. So this is a trinomial. Exactly. It is a trinomial. So you can say it's a trinomial, which is it's a linear polynomial as well as a trinomial. You got it? It is linear because highest exponent of the variable is 1. So it is a linear polynomial as well as a trinomial. Yes or no? No, it is not like that, Vrushak. Exactly. You can say that. Yes. Because x you can write as x raised to the power 1. Correct, you are right. I hope it is clear. Exactly, you have to you have to count the constant term as well, Sumesh. That is correct. So this is a linear polynomial as well as a trinomial. Is it clear to everybody? Simple question. Linear polynomial and a trinomial as well. Suppose it is a 45 minutes only, Nilesh. So suppose I ask you a question from you. Suppose tell me, what type of polynomial is this? Is this a monomial, binomial or trinomial? Mono means 1, bi means 2, tri means 3. No, Naresh, no. 3 variables. See, monomial, binomial, trinomial, you can decide on the basis of number of terms. You got that logic? Terms are 3, therefore it is a trinomial. That's it. What type of polynomial is this? Tell me. Is it a monomial, binomial or trinomial, right? Tell me quickly, guys. No, this is not a trinomial. The reason being, you might feel that it is having 3 terms, but it's not having 3 terms because 3x square minus x square, it will get simplified, right? So this is 2x square minus y cube, correct? So first you have to simplify and then you have to decide. So basically this is a binomial. This is a binomial. It is not a trinomial. I hope it is clear. First you have to simplify, then you have to decide what type of polynomial is this. It is a binomial. So what type? Actually it's a binomial and a cubic polynomial. Correct or not? It's a binomial and the highest exponent of the variable is 3. So you will say it's a binomial and a cubic polynomial. In 2 variables you can say like that. I hope it is clear. It's a binomial as well as a cubic polynomial. Any doubt to anybody in this session? Tell me. These are the very basic things. You cannot say after this session that I don't remember, I don't know the basics of polynomials. I hope it is clear to you, everybody in this session. Right? Okay, there are other questions as well. Don't bother. There are some other basic doubts as well over here, which many students have. So first, can you tell me which of the following is a polynomial? Tell me, guys, which of the following is a polynomial? First tell that. Tell it quickly, which of the following options is a polynomial? See it patiently, Vrushak. I think you are not seeing it patiently. The first one is not a polynomial because it is square root of 7x. So x is inside the square root. So it's not a polynomial now. I can write it like this or not. Fractional exponent of the variable. So it's not a polynomial. First one is not a polynomial. Exactly, the second one is a polynomial. The reason being, it can be written like this: whole number exponent of the variable is there, so this is a polynomial. You don't have to bother about this thing. This is coefficient, numerical coefficient. You don't have to bother about that. No, option D is also not a polynomial. Only option B is a polynomial over here. You see, this will give you negative exponent of the variable. Now, this is in the denominator. You got it? It is in the denominator. Whether it is looking plus, that does not make it positive. You got it? Because this is not in the numerator. You got it? This is also not a polynomial. Option C is also not a polynomial. Only option B. Option D is also not a polynomial. You can simplify. Can I write it like this? 5 by 2 divided by x plus 3x raised to power 3 by 2 by x. So you can use laws of exponents. You see, this is x raised to power 1, x raised to power 1. So can I use laws of exponents? I can subtract it like this: 5 by 2 minus 1 plus 3 into x raised to power 3 by 2 minus 1. Can I do something like this? So this will give you 5 x raised to power, if you simplify, this will give you 3 by 2 plus 3 into x raised to power 1 by 2. 3 into x raised to the power 1 by 2, right? So therefore, you see, fractional exponent of the variable is there. So this is also not a polynomial. Got that logic? Only option B is a polynomial, because over there whole number exponent of the variable is there. Exactly, only option B is the polynomial. Is it clear, Supertech? Is it clear? Exactly, only option B is the polynomial. See, all of the options over here, they are algebraic expressions. They are expressing something in algebra, but all of them are not polynomials. Only option B is the polynomial over here. I hope it is clear. So this can be expanded using something called binomial theorem. I am not explaining it over here, needless to say. See, whole number exponent of the variable must be there, Sujay. I think you have joined the class late. For example, you see, this is not a polynomial because it is having fractional exponent of the variable. This is not a polynomial because it is having negative exponent of the variable. This is a polynomial because the exponent of the variable is a whole number. Exponent of the variable is a whole number. You don't have to bother about the exponent of a constant. You just have to make sure that the exponent of the variable is a whole number. It means it must start with 0, 1, 2, 3, 4, and obviously. I hope it is clear, Sujay. Any doubt in that? Okay. So let's move on to the next thing. Now, can you tell me what will be the answer to this one? Suppose degree of a polynomial f of x is equal to 5. Degree of a polynomial g of x is equal to 4. So can you tell me what is the degree of the polynomial f of x minus g of x? Can you think that logically? A simple question it is. I think you haven't joined on time, Prashasti. What is the degree over here? Tell me. No. Use your logic. Please use your logic. It's a simple question, guys. Degree of a polynomial f of x is 5. Degree of another polynomial g of x is 4. So you have to find the degree of the polynomial f of x minus g of x. Please tell the answer. I want answers from you people. Obviously, I can explain it. A basic trick it is over here. You can just tell that immediately. Just think a bit. I'm giving you some 20 seconds. Just tell that immediately. No, guys. You cannot subtract degrees like that. Use your logic. No. Oh my God. You cannot subtract degree like that, Anubhuti Vrushak. Just think that. Suppose it is given that you have got a polynomial f of x whose degree is 5. So suppose the polynomial, just assume it to be a 5-degree polynomial. I can do that. In the same manner, a polynomial g of x is there whose degree is 4. So you can assume any polynomial of degree 4. Anything you can think in your mind, na? Anything you can think in your mind. So basically you want the polynomial f of x minus g of x, right? So f of x minus g of x will be what? Just subtract and simplify. What will you get? Tell me. You will get something like this. You don't need to calculate this much. I'm just showing you. So basically what will happen? The degree will remain 5 or not? Tell me. The degree will remain 5 only, na? Got that logic? Very good, Supertech. No, it will not be like that, Vrishak. It will remain 5 only or not. If you take a polynomial of degree 5 and you take a polynomial of degree 4, and suppose you subtract the second polynomial from the first polynomial, so the degree of the resultant polynomial will be remaining this only or not? Tell me guys. It will remain 5 only. Is it clear to every student over here? Just comment that quickly, guys. Yep. I hope it is clear. You people are not commenting. How can I know that you're getting it or not? Okay. So can you tell me what about this degree of the zero polynomial? Can you tell me what is the degree of the zero polynomial, guys? You understand zero polynomial? Zero polynomial means the polynomial is p of x is equal to 0. What is the degree of this polynomial? Tell me. It is 5 only, Supertech, that is correct. What is the degree of the zero polynomial, guys? These are very basic things in polynomial. You must have seen them in NCERT as well. And it's not just about grade 9, you must have seen them in grade 7 and 8 as well. What is the degree of the zero polynomial, guys? Tell that quickly. So zero polynomial can be written like this. You can take any variable, suppose x raised to the power 1, you can write it x raised to the power 2, you can write it x raised to the power 3, you can write it x raised to the power 100. You got it? So basically you're not able to decide the degree. You're not able to decide the degree. So therefore the degree of the zero polynomial is not defined. Exactly, option D is correct, Adarsh and Aisha. Very good. You cannot define the degree of the zero polynomial. Very good, Vrishak. Is it clear to every student over here? Now the second part over here, degree of a non-zero constant polynomial. Non-zero constant. It means the polynomial can be anything like this. Suppose it is 5. You can take it 5, you can take it anything, any non-zero number you can take, minus 8 by 3, you can take root 2, you can take any pi. So these are all polynomials. Can you tell me? Degree of the non-zero constant polynomial is 0. It is 0 because if I've got 5, I can write it like this or not. X raised to the power 0 is 1. I can write it like this or not. Tell me. I can write it like this or not. Tell me, guys. Everything over here, this can be written root 2 x raised to the power 0. This can be written as pi x raised to the power 0. So degree of a non-zero constant polynomial is 0. You got it? So anything raised to the power 0 is 1, but 0 raised to the power 0 is not 1 because it is an indeterminate form. Obviously, I am not going into detail of that why it is an indeterminate form. Anything raised to the power 0 is 1 except 0 raised to the power 0, that is not 1. I hope it is clear. So degree of a non-zero constant polynomial is 0 and degree of the zero polynomial is not defined. I hope these things are clear to every student. Vrishak, Adarsh, Supertech, Aisha. Any doubt in these concepts? Okay, so let us move on to the next thing over here, guys. So these things we have already seen. See, constant polynomial, quadratic polynomial, linear polynomial, we have already seen. A constant polynomial is a polynomial of degree 0, linear polynomial of degree 1, quadratic of degree 2 and cubic of 3 and biquadratic of 4 and quintic of 5. We have seen them, right, in this session as well. Now, value of a polynomial for a given value of the variable. Value of a polynomial for a given value of the variable. A simple example, suppose I've got a polynomial p of x is equal to 2x plus 1. Can we find the value of p of minus 3? P of minus 3 means in place of the variable x, you have to put x is equal to minus 3. So just put x is equal to minus 3. So this is the value of the polynomial in place of the variables. So minus 6 plus 1, that is minus 5. So p of minus 3 is equal to minus 5. Is it clear to everybody? So that is the meaning of value of the polynomial in place of some variable. I hope it is clear. I mean, the value of a polynomial for given value of the variable. It can be asked for any value. You have been doing this since junior grades, right? Oh, equation is a different thing, Aisha. You can say, see, what is a quadratic equation? A quadratic equation will be an equation. I mean, you will say, you take a quadratic polynomial and you equate it to 0. Or you can say you can have quadratic polynomials on both these sides. You got that or not, Aisha? or maybe a quadratic polynomial on one side and constant on other side. So basically the question is not correct because there is no comparison between two different things. A polynomial and an equation, they are different things. You got that logic, Aisha? In the same manner, a linear equation is what? You take a linear polynomial, equate it to 0. You take a linear polynomial, equate it to a constant, or you take two linear polynomials and equate them. You got it or not? Only Hindi is not possible, Adarsh. I hope clear hai tumhe. Chalo, I hope it is clear to everybody the meaning of value of polynomial for given value of the variable. Right? Okay. So can you do this question over here? If a polynomial is given q of x is equal to x square minus 3x plus 2, can you find the value of p of 1 plus p of minus 1 minus p of 0? Can you do this and let me know the answer? Only Hindi is not possible, Vrushak. The reason being there are many students who are from South India and they will not be able to understand only Hindi. So I hope तुम समझ रहे हो, वरना मुझे हिंदी बोलने में कोई प्रॉब्लम नहीं है. ठीक है? चलो. Add polynomial. Not able to understand that, Supertech? What are you asking? What is your doubt, Supertech? So you have been given with a polynomial, you have to find the value of p of 1, p of minus 1 minus p of 0 over here. So basically you have to find these values over here. Okay, there is a mistake. Q of x is there, so this is basically p of x, right? It is p of x, then only you can find p of 1. That's it. Then only you can find p of minus 1. So let us find p of 1 first. So it means in place of variable x, you have to put 1 in the polynomial. So 1 square minus 3 into 1 plus 2. So if you simplify, what will you get? 2 plus 1, 3 minus 3, that is 0. So this is 0 only. What is p of minus 1 over here? In place of variable x, you have to put minus 1. So minus 3 into minus 1 plus 2. So what is this equal to, guys? This is equal to 6. Now what is p of 0 over here, guys? P of 0 will be 0 square minus 3 into 0 plus 2. So it is coming out to be equal to 2 only, right? Very simple question. Adding polynomial, not able to understand. What is that question? So over here we have to find the value of p of 1 plus p of minus 1 minus p of 0. So p of 1 over here we have got to be equal to 0. P of minus 1 we have got to be equal to 6 and p of 0 we have got to be equal to 2. So basically we have got the answer to be equal to 4. Any doubt in the question to any student? We are getting 4, Aisha. Addition and subtraction of polynomials is not there in grade 9. So we are not doing those things. I hope you understand that, Supertech. This is Pratham series for grade 9 students on the Infinity Learn class 9 and 10 YouTube channel. And Pioneer series for grade 10 students is going on the Infinity Learn class 9 and 10 YouTube channel. Any doubt in this question, guys? A simple question it was. I hope it is clear. Now you have to understand the concept of zeros of a polynomial. It's a very simple concept. So the first thing is, for linear polynomial, we have to understand the meaning of zeros of a polynomial. Suppose you have got a polynomial p of x is equal to a simple polynomial I am taking 2x plus 5. So 0 of the polynomial means the value of the variable for which the polynomial's value itself becomes equal to 0. You got it? So you have to find the 0 of this linear polynomial. What you will do? You will put the polynomial itself equal to 0 and then you solve it as an equation. So x is equal to minus 5 by 2 is the 0 of this linear polynomial. The reason is what? You can put it over here in the polynomial. In place of x, if you will put minus 5 by 2, you see what you are getting? 2 into minus 5 by 2 plus 5. So basically you will get 0. Minus 5 plus 5 is 0. So the value of the polynomial at x is equal to minus 5 by 2 is coming out to be equal to 0. So therefore x is equal to minus 5 by 2 is the 0 of the polynomial 2x plus 5. Is it clear? Obviously that thing we cannot do in one session, Adarsh. We'll do everything, and that is not there in grade 9. It will be discussed on the Infinity Learn class 9 and 10 YouTube channel only, but for that you have to go in grade 10 class, that is in Pioneer series. I hope it is clear that. Hi Anshul. I cannot take things in between because it will disturb other students. I hope it is clear. Alpha and beta, they are basically zeros of polynomials only. If you have got a quadratic polynomial, you represent its zeros by alpha and beta. If you have got a cubic polynomial, you represent its zeros by alpha, beta, gamma, and so on. I hope it is clear. So any doubt in the zeros of a linear polynomial? Tell me. It's very simple. If you have got a linear polynomial ax plus b, a and b are constants, you have to find its zero. So just put the polynomial itself equal to 0. So x is equal to minus b by a is the zero of this polynomial. So finding zero of a linear polynomial is very simple. It's very direct, right? So maybe now you have to understand how to find zeros of a quadratic polynomial, a 2-degree polynomial. So for a quadratic polynomial, I think one student was asking about the standard form of a quadratic polynomial. So, and we are talking about obviously quadratic polynomials in one variable. So that is ax square plus bx plus c, and obviously a is not equal to 0. The coefficient of x square cannot be equal to 0, because if you take the coefficient of x square to be equal to 0, then this will not remain a 2-degree polynomial. You got that logic? You see, if you take a is equal to 0, this term will vanish. So therefore this will not remain a quadratic polynomial. So a quadratic polynomial can have at most 2 real zeros. So simple thing it is, for example, I'll take a simple quadratic polynomial. Suppose I'm taking x square minus 4. Can you find its zeros, guys? Tell me. P of x is equal to x square minus 4. Can you tell me what are the zeros of this quadratic polynomial? It's a 2-degree polynomial. Can you tell that, guys? So obviously in case of quadratic polynomial as well, you have to put the polynomial itself equal to 0, right? Put that polynomial itself equal to 0, and then you have to solve it as an equation, right? So for that you must be knowing how to factorize a quadratic polynomial, right? So you are there in grade 9. So right now I'm not explaining about quadratic formula. I'm just explaining using factorization. So over here you can factorize. You have studied factorization, right? So what I can do, can I write it like this, x square minus 2 square, and that is equal to 0. Now can we use a square minus b square identity over here? You have studied that a square minus b square is a plus b, a minus b. So therefore this will give you x plus 2 into x minus 2, that is equal to 0. So from here, can I not say that x plus 2 is equal to 0? Or you have got x minus 2 is equal to 0. So you will get x is equal to minus 2 over here and 2 over here. You got that logic? So therefore the zeros of this quadratic polynomial, they are 2 comma minus 2. 2 comma minus 2 are the zeros of this quadratic polynomial. Any doubt in this thing, Supertech, Adarsh, Anshul? Any doubt how we have got the zeros of this quadratic polynomial over here? You can also say that you have factorized it. I have explained how to factorize it. So you can write it x plus 2, x minus 2, right? So from here itself you will see that if you will put x is equal to minus 2 over here, this will become 0. And if this will become 0, this whole thing will become 0. So therefore you will say that x is equal to minus 2 is a 0 of this polynomial. In the same manner, if you put x is equal to 2 over here, this will become 0 because 2 minus 2 is 0. So you can say that x is equal to 2 is a 0 of this polynomial, because putting x is equal to 2 is making the value of this polynomial itself to be equal to 0. So that is the meaning of 0 of a polynomial. So it's a simple example. Is it clear, NRD Gamer, Nimra? Any doubt in that? I hope it is clear. So obviously you have to do some questions on the basis of this. Can you tell me what are the zeros of this polynomial? The first example over here. This is the first one, this is the second one. Can you tell me what are the zeros of this polynomial x square minus 8? Yeah, simple question only it is. What is the 0 of this polynomial, guys? So for that we have to factorize this polynomial again. So you see, can I not write it like this? See, 8 can be written as 2 root 2 the whole square or not. You have studied in the first chapter number systems. You see, 2 square is 4, root 2 square is 2. So 4 2s are 8. So it can be factorized like this using a plus b, a minus b formula. So it will be x plus 2 root 2 into x minus 2 root 2. I hope that is clear. So what are the zeros of this quadratic polynomial, guys? If you put x is equal to minus 2 root 2 over here, this will become 0 and hence the whole expression will become equal to 0. So therefore you can say x is equal to minus 2 root 2 is a 0. In the same manner, if you put x is equal to 2 root 2 over here, this will become equal to 0 and hence the whole expression will become equal to 0. So you can say x is equal to 2 root 2 and minus 2 root 2, they are the zeros of this quadratic polynomial. Exactly, NRD gamer. So any doubt in the first question over here, guys? Tell me. Root 8, yeah, that is 2 root 2 only. Only root 8 is not a 0, NRD gamer. Plus minus root 8 you can say. So that is plus minus 2 root 2 only. What is root 8? Tell me. Root 8 is nothing but, you can write it like this or not. 4 2s are 8 and square root of 2 is 4 only, 4 is 2 only. So therefore you are getting 2 root 2. Clear? I hope it is clear. So therefore option third is clear. Now can you find the 0 of this polynomial z square minus 2z? You have to find the 0 of this polynomial z square minus 2z. So right now I am taking very simple questions. These are very basic questions on the basis of how to find zeros of polynomials. Just explain that, guys. Just let me know the answer quickly. NRD gamers, Suhas, Aisha, Reels, Khuman. I hope I am pronouncing your name correctly, Khuman. Okay, so over here again, see, this is basically on the basis of factorization, which you have studied in grade 7, in grade 8 and in grade 9 as well. You will be studying factorization, right? So over here, can I take z as common? So see, z can be taken as common, so z minus 2 will be left. Z can be taken as common, so z minus 2 will be left. So you see, you can directly say over here that 0 comma 2, they are the zeros of this polynomial. Because if you put z is equal to 0, this is 0. So this polynomial will itself become equal to 0. And if you put z is equal to 2 over here, so 2 minus 2 is 0. So therefore z is equal to 2 is also a 0 of this polynomial. So you will say 0 comma 2, they are the zeros of this polynomial. Any doubt in this? Very good. It's a simple question. I hope it is clear, Reels. Very good, Aisha, you got it correctly. I hope it is clear now, Reels. Is it clear? Okay. Now you see, every time you will not get a question like this. Every time you will not get a question like this. These are very basic questions. Now this one is also basic, but can you find the zeros of this quadratic polynomial? X square minus 4x plus 3. Basically, you must know how to factorize quadratic polynomials, that's it. So those were simple factorizations. This is also simple, you have studied that. So you have studied something called splitting the middle term. So you have to factorize this polynomial using splitting the middle term. Yes, please do that. Can you tell me what are the zeros of this quadratic polynomial? Tell that, guys. 2 and 1. Okay, Nimra is getting only 1. Why, Nimra? Only 1 is not possible there. It's a quadratic polynomial. Although that can also happen that a quadratic polynomial will not have any real zeros. For example, I give a question, x square plus 4. You cannot find a real 0 to this quadratic polynomial. Up till grade 10, you will not be able to find its zeros because it can only be done using imaginary numbers or complex numbers, which you will study in grade 11. Yes. So over here you have to split the middle term. So how will you split the middle term? I am just reminding you. What do you actually do in splitting the middle term? You multiply the first and the last terms in your mind, right? First and last terms in your mind. So x square into 3, I'm writing it, you don't have to write it in your answer sheet. I'm just writing so as to make you understand. So if you multiply the first and the last terms in your mind, you'll get 3x square. Now you have to split the middle term. You have to break down the middle term into two such terms in such a way that the multiplication of those two terms comes out to be equal to 3x square. You have to break the middle term into two such terms whose product is equal to 3x square. So minus 4x can be written as minus x minus 3x, because you see minus x into minus 3x is what? It is plus 3x square only. So therefore I can write it like this, x square minus x minus 3x plus 3, right? So you see this is the first group, this is the first group, this is the second group. Out of the first group you can take x as common, so x minus 1 will be left. Out of the second group you can take minus 3 as common, so x minus 1 will be left. Now out of the whole expression you can take x minus 1 as common, so you will be left with x minus 3 over here. So what are the zeros of this quadratic polynomial, guys? You can directly see they are 1 and 3. So 1 and 3 are the zeros of this quadratic polynomial. You people must have done some mistake. I hope it is clear. 1 and 3, they are the zeros of this quadratic polynomial x square minus 4x plus 3. Any doubt in this question? And needless to say, you have to practice many questions on the basis of these concepts. We are getting 1, 3, I have done splitting the middle term in front of you. I hope it is clear to everybody in this session. Any doubt in this thing, guys? Yep. You can check it as well. If you will put x is equal to 1 over here, what will you get? You see 1 square minus 4 into 1 plus 3. So basically this will give you 3 plus 1 minus 4. So 4 minus 4, that is 0. And if you put x is equal to 3, you'll get 3 square minus 4 into 3 plus 3. So that is equal to, you see 9 plus 3 is 12 minus 12. This is also 0. So basically 1 and 3, they are the zeros of this polynomial. You can put in the polynomial itself and you can check your answer. I hope it is clear. Yeah, you must have done some mistake, no problem. Now one concept is left, and actually two questions are left. They are very good questions. So we'll not do it right now in this session because we don't have time. Obviously there is a time issue as well. We'll do in the next session, but that concept is actually important. So therefore I'm explaining that. It will take 1 minute only. See, for example, I have got this polynomial. It is having zeros 1, 2, right? It is having zeros 1, 2. Now, is this the only polynomial possible whose zeros are 1, 2? Tell me. You got my question? Is this the only polynomial possible whose zeros are 1, 2? Can you tell that yes or no in the chat? Is this the only quadratic polynomial whose zeros are 1 and 2? Right? The answer is no. Suppose I multiply by 5 over here. You see, still this polynomial will have zeros equal to 1 and 2. Suppose I take this same polynomial and I multiply by, suppose, root 8. Still this polynomial will have zeros equal to 1 and 2. So what does it mean? That there are infinite polynomials whose zeros are equal to 1 and 2. So it's not like that suppose you say that alpha and beta are the zeros of a quadratic polynomial. So you'll get a unique polynomial in that case. It is not like that. Infinite such polynomials are possible whose zeros are alpha and beta. You can get any real number value k over here. You can get any real number value k. Obviously this is not equal to 0. This cannot be equal to 0. This can be rational, positive, negative, irrational, anything. So infinite such polynomials are there whose zeros are alpha and beta, or you can take 1, 2 or suppose 1, 3 as well. I hope it is clear to every student over here. So I had discussed this concept over here because on the basis of this concept only we will do these two questions, and these are good questions. We'll take up in the next session because we are already over time now, right? So we'll meet in the next session, guys, with these two questions and other concepts which are to be done in the chapter Polynomials on the Infinity Learn class 9 and 10 YouTube channel. Don't forget to like, share and subscribe, and don't forget to subscribe to the Telegram channel as well. Bye bye guys, we'll meet in the next class. Take care everybody.